What is quantum mechanics? What's its use? And when did it start?
Well, one of the most important phenomena of quantum mechanics was discovered in the dawn of the 20th century at the double-slit experiment. Imagine you have two walls, one behind another, and the first one has two vertical slits. You pick up some ping pong balls and start throwing them toward the first wall. What pattern do you think you'll see on the other wall? Yep, two stripes. What the scientists also saw.
Then the scientists tried the same thing, except with waves, and we can actually try that ourselves. Take these two bulbs as the two slits. When I drop them, they add to create what's called an interference pattern. Then the atomic scientists used particles such as electrons, and guess what happened? Since they're particles, then the same two slits should appear, right? But they didn't. Instead of that, an interference pattern similar to the waves appeared. And to top it all off, when the scientists tried to discover why this was happening by putting a measurement taker before the slits, the particles changed their behavior and started acting like the ping pong balls. To explain why this was happening, scientists came up with various different theories, but an idea from Max Born stuck. Before being measured, the particles are everywhere at once, similar to the waves, but each particle has a different probability to being in each position when we look at it. So on measurement, when they hit the backboard, they pick the position with the highest odds. But how can the electrons be everywhere at once? For that, we need to explore a quantum phenomena called Mr. Superhero Superposition has saved the world again. Hey, Mr. S, how do you switch clothes that fast? Clothes? These are my states, and I do not switch them. I'm all of them at the same time. Oh, but how? Well, even though I'm all of them simultaneously, I have more of a probability to be one state than the other. Oh, dizzy? Yeah, a bit. Is there any way for you to stop and pick one state? Yup, grab those glasses. Through them, you observed me, and I had to pick just one state. But why'd you pick this one? Remember the probability? I had more of a probability to be this state than the others. But what does it mean by the probability of a particle's state, and how exactly do scientists measure that? Well, we can think of this like a basketball game. You know some prior information about the players in the team, like their shooting accuracy and how many games they've won. Variables such as these are also in Schrodinger's wave function equation, like the potential energy of a charged particle at each location, which is the force acting on the particle, the mass of the particle, and the value of wave function at each point in space-time. Using the variables such as these, we can calculate a probability for who's most likely to win. And this probability oscillates, just like in the quantum world, as the game progresses and new information is added. But you don't know for sure who's going to win until the scoreboard flashes and the game's over, just like you don't know what state a particle will choose until you measure it.